So let's say you weigh about 70 kilograms. In that case, you're basically 45 kilograms of oxygen, 12 kilograms of carbon, 7 kilograms of hydrogen, 2 kilograms of nitrogen, 1.5 kilograms of calcium, 700 grams of phosphorus, plus a smattering of other assorted elements. And that's it. Congratulations, you're a pile of utterly ordinary chemical building blocks. There's not a single gram of anything mysterious in there, not even a whiff of special sauce. But is that really the whole story? Or is there something else in you, something that can't be found in the periodic table, and even scarier, might not fit any scientific category at all? Technically speaking, could you harbor something beyond the atoms and subatomic particles that make up your body? Another dimension of you that, if we're being blunt, sounds like something off a paranormal conspiracy show. Let's do a little thought experiment. Take a bag filled with these very same elements and haul it into a busy town square. Dump it out on the sidewalk, and at worst, you'd get a scolding or a fine for littering. Nobody's calling the cops because you spilled some junk in public. But here's the kicker. If you start combining these very same atoms in the exact sequence required to create a human being, at some point, you can't just decide, fuck it, and yank it all back apart. Because in that moment, you've crossed a line. You'd be shredding a living being, and society would slam you with murder charges, full stop. It's as if that mundane pile of garbage suddenly gained a magical new property, something we prize above all else, and punished people harshly for destroying. Think that's too wild? Let's look at something more concrete. In many places where abortion is legal, you can only do it period without a medical reason, up to a specific time limit. Literally, society's stance is that at some particular point, those atoms inside the pregnant person cease to be just atoms and morph into an entity so invaluable that you can touch it. The entire notion of natural human rights, like the right to life, hinges on the premise that there's something transcendent in you, something more than the meat and bones you're made of, or, in Kant's philosophical terms, something beyond mere matter. Particle physics, though, says you could swap out every atom in your body for an identical type, and you'd remain you. Nothing changes. You don't feel a difference. Holy shit, it's literally happening to you all the time. Back in 1954, nuclear physicist Paul Ebersold used radioisotopes to track chemical elements in and out of the body. He concluded that 98% of the atoms in your body get replaced every year. Let that sink in. You're basically a walking ship of Theseus, continuously upgrading parts without ever realizing it. So, statistically speaking, some of the atoms humming inside you right now once belonged to Isaac Newton's brain. Kinda makes you question whether you're just a jigsaw puzzle of random building blocks, or if there's something else that holds you together despite the constant churn, and that's the real mystery. But how do you explain that you feel like the same person throughout your entire life, even though your physical framework is constantly swapping out atoms like it's no big deal? Basically, your original body is decaying. Yes, dying. Yet, your inner self stands firm. Many religions shrug and point to something called the human soul. Wikipedia calls it an immaterial entity that includes your personality, identity, and memories. An entity that might outlast your physical demise. But doesn't science say that's bullshit? What does science even say about such deep questions? I just read the latest book by German theoretical physicist, philosopher of science, and quantum gravity expert Sabine Hossenfelder. It's called Existential Physics, a scientist's guide to life's biggest questions. In it, Hossenfelder tackles these timeless philosophical dilemmas with a scientist's eye. Let's be honest, that's way more compelling than hearing the same old musings from a philosopher or theologian alone. She dives in head first and somehow manages to make it fun. Right after its mid-2022 release, critics basically threw roses at her feet, calling her a beacon of clarity and sanity. By the way, I once made a video about her previous book, Lost in Math, where I briefly touched on how certain scientists wade into philosophical territory and sometimes drag science's credibility into a swampy dead end. Existential physics can be seen as an expansion of those ideas. Hossenfelder is daring, unapologetically German in her directness, and not the least bit shy about roasting her colleagues or readers or even herself. It's entertaining and bracing at the same time. a combo I'm all about. So yeah, I recommend the book, and today, as usual, we'll mull over a few of its points. Hossenfelder claims that a lot of what we dismiss as unscientific or plain ridiculous may actually drive with modern science, and can sometimes make surprising sense. One detail that made me chuckle: Hossenfelder's book begins with a disclaimer that could ring a bell for you loyal viewers. She basically warns that reading it might endanger your mental health. Think twice before diving in, because some truths can't be unseen. Sounds dramatic? Maybe. But let's face it, you wouldn't be here if you couldn't handle a little existential meltdown, right? You might think I'm exaggerating to make dry physics more exciting. Look, we all know I want this book to sell well, so why pretend it doesn't? But the main reason I am issuing this warning is because I am genuinely concerned that this publication may negatively affect the mental health of some readers. Every now and then someone contacts me and writes to say that they've stumbled across one of my essays and now don't know how to move on. They seem genuinely disturbed. Indeed, some scientific facts are hard to digest, and worse, there are no psychologists to help here. I know this from my own experience. The biggest cosmic mind-boggler out there has to be supermassive black holes. We don't know where the hell they came from, and that's not an exaggeration. One of the largest found so far, TON 618, has an event horizon 1,000 times bigger than the distance from Earth to the Sun. Think about that. If you consider Neptune's orbit as the boundary of our solar system, TON 618 dwarfs it by a factor of 17. Imagine taking a spacewalk across that monstrosity. Once you cross its event horizon, you'd float on for 4 more days before hitting the center, where all 40 billion solar masses are squeezed into a singularity. Fun times. But here's the real kicker. The TON 618 we see today is how it looked over 10 billion years ago, basically near the dawn of the universe. And astronomers are scratching their heads because there's no way it should have ballooned to that size so fast, according to our current cosmological models. But wait, there's more. If you think TON 618 is big, check out Phoenix A, possibly packing a mass of 100 billion solar masses or more. That's so huge it's earned a brand new classification, a stupendously large black hole, because supermassive apparently wasn't enough. So, do we really understand how the universe began, or how it's been running? Did the past even happen the way we think? It's pretty much accepted that our universe is around 13.8 billion years old. And the standard thinking is that all our known physics kicked in almost immediately after the Big Bang, like within a fraction of a second. But maybe we're missing a piece. Could it be that some other laws of physics once reigned, allowing these cosmic beasts to form so quickly? Or is it possible that what we calculate as 13.8 billion years might actually be 100 trillion years, and we're just clueless? Foolishness? Possibly, but the honest answer is that no one knows for sure. We've never seen the laws of nature change, but that doesn't prove they can't. As physicist Sabine Hossenfelder points out, it's not hard to come up with mathematical laws that would look indistinguishable from those confirmed so far, but which would blow up the solar system tomorrow. Not that anything speaks in that favor, but nothing speaks against it either. We can't test what laws of physics existed billions of years ago by running some neat lab experiment. We rely on our current laws, stuff we've only studied for a blink of human history, and then extrapolate. We assume the speed of light didn't randomly drop to 2 kilometers per hour 6 billion years ago, but that assumption is faith, not proof. We're just using the scientific approach with the data we have and hoping the cosmic dice haven't changed sides. This is the problem of induction that David Hume ranted about. You can't logically predict that nothing unpredictable will ever happen. The universe owes us zero consistency. We can guess, we can model, but at the end of the day, we're basically trusting that tomorrow's sunrise will behave like yesterday's. Could the laws of physics morph overnight? Probably not. But we can't swear on it. And that, my friend, is the cosmic punchline. We're building entire theories on borrowed time. When, as an undergraduate, I first learned about Hume's problem of induction, I was puzzled. I felt that someone had pulled the rug of reality from under my feet, exposing a vast, gaping void. Why hadn't anyone warned me about this? Isn't it funny how once you grasp that nature's laws might randomly morph, you start looking at headlines like, "Earth is suddenly accelerating its rotation and no one knows why," with a whole different sense of dread? The very thought that the world could be fundamentally chaotic, defying any explanation we try to slap on it, grates on our nerves. We can't stand the idea that every conclusion we draw might rest on shaky assumptions, but maybe that's just how it is. In 97% of all Wikipedia articles, if you follow the first link and repeat this in every subsequent article, you end up with an article related to philosophy. Philosophy is where our knowledge ends, and the scientific method is no exception. Does the scientific method work? Yes. Why does it work? Ultimately, we don't know, and because we don't know why it works, we can't be sure that it will continue to work. Let's be real, there is no ironclad definition of what we call science. The boundary keeps shifting. You want proof? Take Isaac Newton, the rock star who basically birthed modern physics. His very name is science in the eyes of today's world. And yet, guess what he spent most of his career on? Alchemy. Yep, the man behind the laws of motion devoted 30 years of his life to hunting for the philosopher's stone, cranking out over 1.2 million words on the topic. Way more than you'll find in your average novel, which is around 80,000 words, in case you're curious. Newton had the world's top-tier alchemical library and poured decades into trying to turn metals into gold or unlock eternal life. He didn't see any difference between that quest and discovering gravitational law. So, if you ask Sabine Hossenfelder, and many of us do, what is science right now? Science is the search for useful descriptions of the world. By useful, I mean that they allow us to make predictions for new experiments or quantitatively explain existing observations. The simpler the explanation, the more useful it is. Now throw that perspective back into the pot with the idea that the laws of nature could just change. It makes me think of the so-called omphalos hypothesis, which tries to reconcile scientific data with the Holy Scripture, claiming God created the universe a few thousand years ago, but intentionally made it look far older. Bertrand Russell took that one and ran with it, basically saying, why bother with thousands of years? Maybe the universe popped into existence 5 minutes ago, memories and all. So is it possible that our universe isn't actually 13.8 billion years old, but just a couple millennia? This question is well answered by British physicist Tim Palmer, whom Hossenfelder interviewed for her book, and who, when asked if he was religious, answered an emphatic no. So I tried to reflect, is it possible to imagine a situation in which such a belief that God created the universe 6,000 years ago would not be silly and would not completely contradict everything we understand about science? He asks, what does creation even mean in the first place? How do you create an atom? Modern science can only scribble out equations describing what atoms do, not what they are at their core. In other words, from a hardcore scientific standpoint, the real world and our math describing it are indistinguishable. It's like saying that a map and the territory it describes are the same thing. You've probably heard this analogy. What do we even mean by the word creation? Let's consider, for example, the creation of atoms. What are atoms? Well, all science can say at this point is that we can describe atoms with equations. We have mathematical laws, and whatever you want to know about an atom, an equation will tell you what it does. But math won't tell you what an atom is. Is an atom just math? Is math all there is? Or is there something, substance or otherwise, that makes the stuff real and is not part of the modern scientific canon? No one knows the answer to that question. Hawking, in his book A Brief History of Time from the Big Bang to Black Holes, famously asked the question, what breathed fire into the equations that create the universe? There is probably something else in the universe around us that is not just math. And at least purely intuitively, it's hard to disagree with that. Of course, you may have a different opinion, like the physicist Max Tegmark, who thinks that no, the universe is literally math. You're welcome. But if you don't think so, Tim Palmer continues, I'm not trying to advocate this, but you could say that God created the universe using mathematical methods, and that math describes how clusters of dust gather and get hot enough that nuclear fusion starts producing energy, elements, and so on. It's all just math. And then 6,000 years ago, God got bored with it, and he said, "This is a bit boring, now I'm going to do something real." And he waved his magic wand, and that's when real things appeared. From a scientific standpoint, how do you disprove that? How do you pin down the age of the so-called mathematical universe versus the real universe? Modern science basically rests on math. Chemistry is founded on physics, and physics is grounded in math. So the claim that God turned math into matter 6,000 years ago might sound bizarre, but it's not necessarily anti-scientific. It's what Tim Palmer calls anascientific, basically a parallel track that mainstream science can't address because it's beyond the scope of current methods. There are some things that we're really profoundly ignorant about, and this is one of them. Is math just a tool to describe the world, or is it the world itself? We can argue about that, but scientifically we can't say anything about it. If we accept there's a boundary separating scientific from anascientific ideas, maybe we can be clearer and bolder in our theories. And who knows, maybe we'll figure out how to nudge that boundary. Recent observations suggest our universe contains at least 200 billion galaxies, and they're not just scattered willy-nilly. Gravity pulls them into clusters connected by filaments that can stretch hundreds of millions of light years, forming a cosmic web that uncannily resembles a human brain. In 2020, astrophysicist Franco Vazza and neuroscientist Alberto Folletti ran the numbers on the structures of the cosmic web versus the human brain and found striking similarity. Could our entire universe be some sort of giant brain with our galaxy playing the part of a single neuron? According to Sabine Hossenfelder, that sounds like a stretch. For one, the universe is enormous and nothing can exceed the speed of light. It takes hundreds of millions of years for signals to move between galaxies, meaning that since the Big Bang, about 14 billion years ago, the universe could have managed maybe 1,000 such exchanges. Our brains churn through that many signals in 3 minutes. Plus, the universe keeps expanding, reducing future connections. But here's the flip side. Hossenfelder points out that if tiny wormholes permeate the universe, distant regions might be connected almost instantaneously. Then, the cosmos might communicate at speeds far beyond our usual physics, opening the door to a universe that could think, just not with the neurons we're used to. So maybe the universe is an ephemeral behemoth mind, or maybe it's just cosmic spaghetti. At the end of the day, science has no definitive answer. We can only keep our eyes open and hope we're not missing some grand neural flicker in the blackness of space. After all, if the universe did have thoughts, would we even notice? Or are we too busy dissecting equations to hear the cosmic neurons firing around us? These connections would be too small for us, or even for elementary particles to pass through. They would be only 10 to the minus 35th power meters in diameter, but they would closely link the geometry of the universe to the universe itself, and there would be many such links. Physicists Fotini, Markopoulou, and Lee Smolin estimate that there would be about 10 to the 360th power of them in our universe. By comparison, there are only 10 to the 15th power in the human brain. And since these connections are in any case non-local, that is, they ignore distances, it doesn't matter that they are expanding in space. I have no particular reason to believe that these non-local connections really exist, or that if they did, they would really allow the universe to think. But I also can't rule out the possibility. As crazy as it sounds, the idea that the universe is intelligent is compatible with everything we know so far. Can the universe have consciousness? Of course not. What the fuck? Can the universe think? Does the universe have consciousness? Normal people don't ask stupid questions like that, right? Well, guess what? These stupid questions matter. Here's why. There's something called the explanatory gap. Without a shadow of a doubt, that you have consciousness, a sense of self. Yes, I can see some of you rolling your eyes thinking, not the consciousness debate again. But plenty of folks dismiss the topic altogether. They are the minority, though, because consciousness remains one of science's biggest enigmas. In 2005, Science magazine listed 125 open questions in science. You'd think consciousness might top the list, but nope. Number 1 was, what is the universe made of? And let's be honest, it's well deserved. We're clueless about 96% of the matter and energy swirling around us. Nobody really knows what dark matter or dark energy actually are. But consciousness snagged the second spot. What is the biological basis of consciousness? That's huge, because while it's blindingly obvious to you that you're a conscious being, science has zero surefire method to prove someone else is conscious. The best we can do is guess. This isn't a new problem either. 4 centuries ago, Gottfried Leibniz, philosopher, physicist, mathematician, proposed a thought experiment on this very mystery. It must be recognized that perception and what depends on it cannot be explained by mechanical causes, that is, figures and movements. And if there were a mechanism designed to think, feel, and perceive, we could enter into it as a mill. And if that were the case, when we visited it, we would find only parts that push against each other, but nothing that would explain the perception. Leibniz knew a thing or two about mechanisms. He invented a bunch of devices, including a mechanical calculator that ran the show for 300 years, right up until the electronic calculator replaced it. And while Leibniz believed human logic could be crunched by these machines, he couldn't fathom how a mechanism could generate actual subjective experience. The English biologist Thomas Huxley was just as perplexed by consciousness. In 1869, he wrote that something so remarkable as a state of consciousness results from the irritation of nervous tissue is as inexplicable as the appearance of a genie when Aladdin rubs a lamp. Huxley, an expert in anatomy and neuroanatomy, compared the human brain with those of other primates, using their similarities to bolster Darwin's evolution theory. But he found nothing in the brain that could account for consciousness popping out of mere biological structure. Even Sigmund Freud threw up his hands. We can speak of 2 aspects in regard to what we call the psyche. First, the organ of the body responsible for it, and on the other side, the workings of consciousness. Everything that lies in between is unknown to us, and does not contain any direct connection between these 2 extremes of our knowledge. Why does a bunch of ordinary physical elements spontaneously conjure up subjective experience? It's a riddle that stumped thinkers 400 years ago, and it's still stumping us now. Let's face it, when normal people look at the raw insides of the human body, they can't help but mutter, "How the hell am I this?" That's the explanatory gap in a nutshell. We can't bridge the chasm from a hunk of physical matter to the fact that it's experiencing something. Figuring this out is not just philosophical navel-gazing, it has real consequences. For instance, when a patient is in a vegetative state after a catastrophic injury, how can we tell if they're aware of what's happening before we pull the plug? A robust theory of consciousness is critical. And second, the day's coming, maybe sooner than you think, when AI and robots match or surpass human thinking. How do we know these machines aren't conscious? Do we have the moral right to build them, run them, and then casually shut them down? Because look, even though robots are silicon and we're carbon, there's no known law that forbids consciousness from popping up in any platform with the right configuration. The idea that consciousness could be realized in multiple ways across different substrates goes by the name multiple realizability. In theory, your exact conscious experience could be copied onto a system that's nothing like a biological body. Everyone's heard of downloading consciousness into a computer. It's old hat in sci-fi. But if multiple realizability is genuine, the real-life implications are bonkers. You might laugh now, but the thought of your entire self transplanted into a machine or some other bizarre substrate is a mind-bender that we can't just shrug off. The question is, when will we face it? And more importantly, how? Imagine rounding up all 1.5 billion people in China, sticking each one on a massive field and telling each person, "You're now a single neuron in a giant brain. Your job is to make phone calls to certain other neurons when you get a signal." That's essentially the infamous Chinese brain thought experiment. Its most popular version appeared in 1978 from American consciousness philosopher Ned Block. The punchline: this colossal network of phone-calling humans is supposed to mimic how neurons fire and relay signals in an actual brain. Each Chinese citizen has a phone and a list of contacts. No words are exchanged, just the fact of a call happening, like neuronal spikes. Put 1.5 billion Chinese on the field, wire them up, and boom, you have a gargantuan replica of a brain's structure. According to some philosophers, this setup wouldn't just be a silly game. It would have a unified consciousness all its own. It could feel pain, even though each individual Chinese participant wouldn't feel a thing. You might argue this monstrosity would be too slow and clumsy to function, but Ned Block says it's not obvious why timing matters for consciousness anyway. Yeah, it sounds totally schizophrenic, and Block offered it partly to show how absurd things can get. But guess what? Plenty of thinkers don't think it's absurd. Take Daniel Dennett, a famous philosopher who insisted in his book, Consciousness Explained, that the Chinese brain could in principle produce any mental state a regular human brain does. Why assume a lump of quivering gray matter is more fit for consciousness than a massive group of people acting in perfect sync? Let's be honest, our intuition has misled us plenty of times, like when humans swore the Earth was flat or motionless. We know of no fundamental law that says consciousness can't arise in a phone call-based human network. For all we know, it likely emerges in any system that handles information in a complex enough way. The human brain is just the only system we're absolutely certain about. Sure, other animals might also have consciousness, maybe not just on-off, like a switch, but on a spectrum. Your dog, a chimpanzee, a pigeon, a lizard, even a dragonfly. Maybe they're a little bit conscious. Exactly where the line between conscious and not conscious falls is a total mystery. Maybe it's between humans and chimps, or pigeons and lizards, or insects and bacteria. Nobody has a damn clue. But it's probably safe to say that for a system to feel anything at all, it can't just be a single electron. It needs some threshold of size and complexity to process information. And here's a mind bender. If we can't even figure out what's going on with the consciousness of animals, which might be simpler than ours, what makes us think we could identify a higher level consciousness if it exists? Say in the internet, entire nations, or maybe even in the universe itself. That's the kind of question you debate late at night in a friend's kitchen, glass of wine in hand. Could the whole damn universe be self-aware? Shrug. Nobody knows. But that doesn't stop us from imagining the possibilities. According to currently established laws of nature, the universe cannot think. However, physicists believe that the universe has many non-local connections because this would solve several problems in existing theories. This is a speculative hypothesis, but if it is true, the universe may have enough fast communication channels to possess consciousness. So you see, all these so-called crazy speculations about a conscious universe stem from one simple, brutal fact. We have no idea how mere matter starts having experiences, or why it would even need them in the first place. You might wave this off and say, yeah, humans have consciousness, so we can make conscious choices. Well, guess what? You just fell right into the trap. Back in 1805, a then-nobody artist-poet named William Blake made an engraving you might actually recognize. Maybe you've heard of it if you read the first Hannibal Lecter novel, Red Dragon, or saw the movie version. The plot revolves around a maniac who's obsessed with Blake's painting The Great Red Dragon and the woman clothed with the sun. As is often the case, Blake shot to popularity only after his death, but in 1805 he produced one of his most notorious pieces, Newton. Blake hated Isaac Newton, and in this engraving he shows the scientist almost completely naked, hunched low to the ground. Newton's using his white robe as a makeshift canvas, while he draws diagrams with a compass. But the biggest eye-catcher is Newton's blank expression. No trace of emotion. Some people say he's just super focused. Blake implies something a lot more eerie. Even though Newton is stooped over and blood must have rushed to his face, it is nonetheless whiter than the rest of his body because it is the face of a dead man. According to Blake, art is the tree of life. Science is the tree of death. He despised Newton's scientific method because it breaks nature down into pieces to figure out how it works. That reductive approach is the basis of modern physics. But for Blake, it equaled decay and death. He believed you can't truly understand living nature by turning it into a cold, dissected carcass. In the engraving, Newton himself is trapped in a lifeless rock because he's as dead inside as his diagrams, dried-out sketches that claim to capture the entire universe. To Blake, that was a pathetic excuse for understanding reality. So what the hell does this have to do with the rest of our story? Well, each of us believes we can do one very suspicious thing that seems to defy the universe's bedrock laws. Laws so ironclad that if they decided not to work anymore, matter itself could instantly collapse. Actually, that's an understatement. It's impossible to calculate exactly what would happen if these laws just stopped. They're that vital. And if you right now consciously decide to clench your left or right fist, you're supposedly violating every single one of those laws. Think about it. From the Big Bang onward, the universe has unfolded in a chain of cause and effect. Everything is an outcome of a previous event. If you want a visual, imagine the entire universe as a colossal pool table with balls colliding and rolling, each movement triggered by what came before. There's no just because motion. You can trace everything backward and theoretically forward in time. That's the principle of causal closure. The physical world is a sealed system of cause and effect. If it weren't, reality would dissolve into chaos, balls zipping around randomly, stopping or starting without rhyme or reason, bouncing in bizarre, untraceable ways. But that doesn't happen. Not in our world. Yesterday's universe dictates tomorrow's, and so on. It's how physics works. Yet here we are, claiming we can just will ourselves to do something, like pick up a coffee mug or scratch an itch, without it being fully determined by the cosmic domino effect. How does that not break the rules? Maybe it does. Or maybe we're all delusional. Either way, Blake would say Newton's little diagrams don't capture this puzzle, the riddle of consciousness, free will, and whether a bag of atoms like you can truly do anything that wasn't already decided by some cosmic chain reaction set in motion eons ago. The currently established laws of nature are deterministic and contain an element of randomness from quantum mechanics. This means that the future is predetermined, except for random quantum events that we cannot influence. Remember what you are: 45 kilograms of oxygen, 12 kilograms of carbon, and so on. Just a bunch of unremarkable chemical elements, the exact same atoms obeying the same physical laws as everything else in this universe. Under the reductionist lens, if we break you down into atoms, learn their properties and interactions, we can predict your every move, every choice in advance. Scary, right? And I know some of you are rolling your eyes, muttering, ugh, more talk about humans not having free will. Robert Sapolsky's hammered this to death already, but don't be so quick to shrug. Consider what Sabine Hossenfelder says. As a specialist in particle physics, I must inform you that the available evidence suggests that the whole is the sum of the parts, neither more nor less. Countless experiments over millennia have confirmed that objects are made up of smaller objects, and if you know what small objects do, you can tell what larger objects do. There are no known exceptions to this rule. However, I am not in favor of reductionism. Our knowledge of the laws of nature is limited. Much remains to be understood, and reductionism may fail in some subtle ways. On one hand, if you take it seriously, it's obvious we don't have free will, like you're just a billiard ball with illusions of grandeur. The only reason we think we're choosing freely is because we don't know the outcome of our internal process until it finishes. As Ludwig Wittgenstein said, free will consists in the fact that future actions cannot be known now. But here's the kicker. We hate this idea that we might just be biological puppets. We also reject that genetics could determine a huge chunk of who we are. Remember the outrage when Darwin published his theory of evolution? People were furious, and not just random yokels, but the era's smartest elites. Cartoonists depicted Darwin as a monkey in newspapers worldwide. Jerry Allen Coyne wrote in Why Evolution is True, no scientific theory has provoked such anger and fear and such psychological resistance. Why? Because if we're really just animals, then we're basically soulless biological robots. Descartes' automata. Mention human instincts in polite conversation and watch how fast people jump to claim humans don't have such things. We all recoil from the notion that we might be nothing but mechanical marionettes on cosmic strings. And yet, from an evolutionary standpoint, there must be some advantage in our fiercely defending the belief in our own free will. I haven't heard a truly convincing explanation of why, though. Look at our civilization. The entire legal system is built on the assumption of free will. No matter what crime you commit, you won't be jailed if it's proven you had no awareness of your actions, like being in a state of passion. Robert Sapolsky says we should abolish punishment for criminals altogether. Good luck. I doubt society would ever let that fly, at least partly because we believe criminals have a choice, and I'd love to see the reaction of folks who champion Sapolsky's view if they're ever a crime victim themselves. I'm not saying they're wrong, but let's be real. There's often a huge gap between what people claim to believe and how they actually behave. We can deny free will all day, yet the average person lives as though they do have it. The funny thing is, it's not obvious why we'd need that illusion. I have found that many people reflexively reject the possibility that human consciousness arises from the interaction of multiple particles in their brains. They seem to cling to the idea that there must be something else to consciousness. And while people with a scientific mindset don't call it a soul, that's exactly what they mean. They are looking for something mysterious, inexplicable, and amazing, something to make their existence special. And you know, it's hard to blame them. Plus, Hossenfelder goes even further and claims that our biological shell could be completely replaced by an artificial one altogether. As far as we know at this point, the physical substrate of a being or object can be replaced by something else. As long as this replacement maintains a characteristic relationship and interaction, it should also maintain functioning, including consciousness and identity. So here's the conundrum. Consciousness sounds like some kind of ghost in the machine, entirely unlike any physical process we know. It practically screams non-physical. But can anything in the universe be non-physical? The honest answer is, we don't know. Physicalism, the idea that everything is physical, is just a philosophical stance, not a proven scientific fact. If consciousness does turn out to be non-physical, then according to the principle of causal closure, which states that all physical events are caused by other physical events, it couldn't influence anything physical. It's the classic mental causation problem. A ghost can't push a door open without shattering physics. Just ask Patrick Swayze's character in Ghost. So, if consciousness is exactly what it seems to be, freely doing its own thing, then we've got a paradox on our hands. Can physics fix that paradox? The power to govern the motion of matter, daily manifested in the miracle of human free will, and in generations of plants grown from a single seed, is infinitely different from any possible result of the accidental collision of atoms. Kelvin was wrong about plants, but maybe free will isn't as cut and dry. The simplest explanation is that consciousness doesn't actually influence anything. It's just along for the ride, and we only imagine it's doing stuff. But then, why do we even have it? Another option is Hugh Everett's multiverse interpretation. For example, physicist David Deutsch believes free will can coexist with physics if every possible event branches off in a parallel universe. But come on, if there really are zillions of universes, is your consciousness just flipping a cosmic coin to decide which branch you land in? That hardly sounds like free will. It's more like you're riding a quantum wave of inevitability. But if you do buy the multiverse, maybe you can literally split realities at will. Theoretical physicist Sean Carroll has mentioned a cheeky method, and Sabine Hossenfelder wrote about it too. There's a phone app called Universe Splitter, not an ad, which supposedly uses a remote quantum device to send a photon into an either-or state. If the many worlds theory holds, that photon goes both ways in different universes, and the app tells you which universe you ended up in. Wild, right? As for our original free will paradox, let's remember that causality is the bedrock of all known physics. Every effect has a cause, and that chain of cause and effect can't just snap for no reason. But is it truly impossible for causality to break? According to modern physics, There's at least one phenomenon that might smash causality, described by George Musser in Spooky Action at a Distance. It's a notion that real, actual violations of cause and effect could happen, thanks to some deep weirdness in quantum mechanics and the structure of space itself. Speaking of space, here's the million-dollar question. What's it made of? If we're the ultimate reductionists, we want to find the building blocks of space. But if you think bricks of space are smaller than space, well, good luck. Concepts like small or big don't even apply when you're talking about the fundamental fabric of the cosmos. The only constant in all this, our confusion, because maybe space and everything in it follows rules we haven't even begun to grasp, and that includes consciousness, free will, and the possibility that we're all just illusions dancing in an uncharted quantum playground. They must have no size or position. They extend everywhere throughout the universe and nowhere by virtue of the fact that it is impossible to point to a place. What does it mean for entities to have no position? Where must they be located? These questions about the very nature of space are so outrageous, it's nearly impossible to put them into human language. We don't even have the words to describe them, and we can barely visualize what they imply. But here's the kicker. Space might be nothing more than one specific, fleeting phase of the universe's deeper chaos. According to George Musser, it could be that most possible states of the universe are actually non-spatial. So the familiar 3D stage we're standing on? It's the exception, not the rule. The existence of space-time is a completely uncharacteristic state. It requires the existence of special conditions. For a crude analogy, think about water. Water can be liquid, ice, or steam, even though it's all the same, H2O. The gaseous state, steam, is insanely chaotic. Just watch a boiling kettle. The solid state, ice, is more ordered, with molecules locked in a nice little lattice. But that chaos doesn't vanish. It's just biding its time. The same sort of flip-flop might happen with space. Most of the time, the building blocks of space could be churning in a monstrous entangled chaos, but once in a while, they snap together into a neat structure we call space-time. The Big Bang might have been one of those moments. As George Musser puts it, the mind-bogglingly complex network of interactions is reduced to a few numbers we call position and time. It's like the universe went from a swirling primal mess to a clean lattice, much like ice. But, as with ice, that underlying pandemonium hasn't disappeared. It's lurking, waiting to burst out. And guess what? That's exactly what might be happening with black holes. In a black hole, the fundamental building blocks of space revert to their more natural, jumbled state. This meltdown of structured space blows up normal cause and effect relations. If you try writing an equation for something falling into a black hole, the math breaks at the singularity. That's why black holes and the Big Bang both have singularities. Reality itself unravels there. And here's another mind-bender. Separate hydrogen and oxygen atoms aren't wet, but mix them and you get water. Same idea. Space itself might be emergent, arising from some insane underlying structure that doesn't look anything like space. That's emergentism, properties of a system that can't be reduced to the properties of its parts. As Nima Arkani Hamed's string theorist says, when we reason about emergent space-time, it must arise from some underlying structure that is very far from what we are familiar with. So there you have it. Maybe space is just a rare, fragile phenomenon, and black holes are cracks where the old chaotic storm leaks back in. We're floating on the iced-over surface of the universe, while cosmic monsters lurk in the murky depths below. Everything around us is emergent, a grand interplay of atoms. Sounds fancy, but it's actually straightforward. Pile atoms together in the shape of a cat, give them the right kinetic conditions, and voila, the cat's alive and purring. No magic wand needed. Of course, those individual atoms can't purr by themselves. That's emergent behavior. The whole has properties none of the parts possess on their own. And from everything we know, this is weak emergentism. Sure, we can't yet derive, say, the laws of cat behavior from the standard model of particle physics, but that's mostly because we don't have enough computing muscle. not because it's impossible in principle. All cause and effect flows upward, from tiny building blocks to big objects. Atoms make up your brain, and your brain's you. Meanwhile, philosophers wrestle with strong emergentism, which claims there are fundamentally new phenomena that no amount of knowledge about the underlying components could ever predict. It's a direct challenge to reductionism, saying the whole is literally more than the sum of its parts. Problem is, we have zero real-world examples of true, strong emergentism. If you wanted to prove reductionism false, you would have to show that describing a system in macroscopic terms leads to different predictions than you would get from its microscopic description. No one has ever been able to do this before. Again, not because it would be impossible. You could probably try to imagine a world in which the behavior of atoms depends on the behavior of planets, rather than the way around. But as far as we can tell, this is simply not the case. In fact, the problem is that, as far as we know at the moment, strong emergentism is impossible. Strong emergentism smacks of pure magic. It's like you build a robot, program it meticulously, then out of nowhere it claims it feels emotions and starts acting unpredictably. Crazy, right? Except human consciousness might be pulling exactly that stunt. We see neurons firing, but nowhere do we find this weird awareness. It's as if matter itself harbors some bizarre hidden property that shows up as consciousness. Suddenly, people are flirting with the idea that maybe the entire universe has a mind. You've heard that one. So, yes, consciousness might be our first real candidate for strong emergentism. Then what? Consider the idea George Musser throws down. Using a law of physics, we can relate every choice we make to the distribution of matter at the dawn of time. This does not necessarily mean that your will is unfree. Freedom may be an emergent property, not possessed by individual particles, but possessed by a system of particles. As far as you are concerned, your choices may be absolutely free until you make them. Nevertheless, philosophers, scientists, and students having conversations late into the night are still arguing about this topic. Or as Nobel Prize-winning physicist Philip Warren Anderson once said, more is different. And let's not forget that classic Benjamin Libet experiment, where scientists saw brain signals hundreds of milliseconds before a subject felt like they made a choice. Some people interpret that as proof we don't have free will, since the brain decided first. Robert Sapolsky loves citing this. But to be honest, I've never grasped how the brain decided first automatically means no free will. Even if free will isn't real, it's not obvious that's the final takeaway from Libet's data. There's a huge gap between detecting readiness potentials in the brain and concluding that you're nothing more than a puppet. Neuroscientist Kevin Mitchell, in his book Free Agents, How Evolution Gave Us Free Will, addresses this knee-jerk reaction that if the brain mechanism lights up during decisions, we must be nothing more than those mechanical flickers. There is this idea that if some mechanism is activated inside the brain when we make a decision, it supposedly follows that decision-making is nothing more than the action of that mechanism. I don't think that's a valid point of view. I think it just follows that we need to use some biological mechanism to make decisions. Mitchell insists our biology has evolved us into free agents over billions of years, conjuring a completely different type of causation from anything previously observed in the universe. Meanwhile, the original mastermind behind those famous readiness potential experiments, Benjamin Libet, ended up claiming consciousness wasn't just a brain byproduct at all. He posited a conscious mental field that can freely influence many nervous functions, giving us at least a shot at real free will. Sure, it sounds far-fetched, but it also shows these debates over consciousness and free will are anything but settled. Where does physicist Sabine Hossenfelder land? She leans toward no free will, but grudgingly admits we can't rule it out. The only way in which free will would make sense is if the inference from a microscopic theory fails in some cases for some reason. Then strong emergentism could be a real property of nature, and we could observe macroscopic phenomena, including free will, that are truly independent of microphysics. It may happen that in computation we encounter a singularity beyond which we simply cannot go, either in practice or in principle. We currently have no reason to believe that this is the case in the actual microphysics operating in our universe, but it may turn out to be the case when we understand the math better. So, if you want to believe in free will that is truly governed by laws of nature, independent of the laws of elementary particles, then the possibility that the derivation of macro-physical laws leads to a singularity seems most reasonable to me. It's unlikely, but it's compatible with everything we know so far. Personally, I kinda like the notion that human beings are like black holes in biological form, masses of swirling chaos, their inner workings cloaked in impenetrable mystery. But on the flip side, if we really do have free will, that's a towering burden of responsibility for every decision we've ever made. Think about it too hard, and you'll get dizzy. There's a Latin term, cause in itself, traditionally reserved for God, because God supposedly depends on nothing but himself. The big claim is that God handed down a spark of that creative freedom to humankind, making us in his image. So if we truly have free will, we're basically cosmic mini-gods, the cause of our own actions. That's an epic aspiration, or a terrifying load to carry. It might not shock you to learn that physicist Sabine Hossenfelder is an agnostic. In plain terms, she believes we can't truly know what's out there, not directly anyway, because we're stuck perceiving the world through our limited senses and minds. Therefore, we'll never confidently declare that God or gods either does nor does not exist. At the same time, Hossenfelder has no beef with believers. You might say, okay, obviously you can't prove God doesn't exist, but what if God showed up, parted the clouds, and performed legit miracles? Wouldn't that be proof? I'll recall Arthur Clarke's third law. Any sufficiently advanced technology is indistinguishable from magic. So even if some cosmic being floated down radiating light, how do we know it's God and not an ultra-advanced alien with a fancy bag of tricks? Or a glitch in our simulation? Or maybe we just snapped and imagined it all. Our capacity for cognition has hard limits, which is basically agnosticism in a nutshell. Sometimes the only scientific answer we can give is we don't know. So it seems likely to me that in our ongoing process of discovering knowledge, religion and science will continue to coexist for a very long time to come. This is because science itself is limited, and where science ends, we look for other ways to explain. In other words, science is just a powerful tool to describe the world, but it doesn't rule out a creator, nor does it require one. It's not that I want to be nice to religious people just for the sake of being nice. To begin with, I'm not exactly known for being nice. But more importantly, scientists who claim, like Stephen Hawking, that the existence of a creator is impossible, or, like Victor Stenger, that God is a falsifiable hypothesis, demonstrate that they don't understand the limits of their own knowledge. When eminent scientists make such self-righteous statements, I cringe. Now, if we're not starting from any specific religion, but just a generic concept of an omnipotent God, ask yourself, if we somehow confirmed that an all-powerful deity truly exists, would we even like that conclusion? Because we'd instantly realize we're living in a wildly unpredictable cosmos, thanks to a free-willed, all-powerful agent who can do literally anything. Any stupendously large black hole is preschool-level tame compared to that scenario. And there's no obvious reason why such a God would play by our rules of goodness or justice. Even worse for us, we hate unpredictable dangers. From peeking into the extra room in a hotel suite, no matter how dead tired we are, to unraveling cosmic laws, we're the galaxy's most curious species. Curiosity is basically our weapon against unpredictability. But a God with infinite power is fundamentally unknowable, the ultimate cosmic wild card. If he's truly like us or we're like him, that's not much comfort either. Who says he has to be benevolent? Are we always benevolent? As Niccolo Machiavelli put it in The Prince, men are always bad until necessity compels them to goodness. What could force an omnipotent being to be good? There's a movie that toys with this idea. What if we did discover a godlike figure? who also happen to look like us. You might be thinking of some grand theological epic, but no. Try Batman versus Superman. Bruce Wayne's entire argument is that Superman must die simply because he's too powerful and too unpredictable. He's basically saying humans destroy anything that poses an existential threat. Carthage must be destroyed, right? Director Zack Snyder tosses up a big question. If a god walked among us, would he or she actually meet our naive expectations of goodness? Or would it turn out that God's as flawed as we are? And modern physics suggests that if the universe has a creator, it might be just as flawed as you and me. Because guess what? There's a real scientific theory that says if we took something not too massive, like your computer chair, and extracted all its atomic energy into a tiny region of space, we could create a brand new universe. Yes, that basically makes us gods, in the rawest sense of the word. Alan Guth, Andre Linde, and plenty of other physicists have shown a finite amount of energy can spark a universe. According to the most optimistic estimates, it would take about 10 kilograms of pure energy to create a new universe. Sure, that's a million miles from our current tech, but the theory doesn't see any fundamental barrier. Someday maybe we can do it. This nascent universe would rapidly grow and separate from our own, similar to a drop of water dripping from a faucet. From the outside, the newborn universe would briefly resemble a tiny black hole. It would disappear in a split second. We will never know if there were inhabitants and what happened to them. It wouldn't be destroyed, just zipped off into its own space-time, with its physical constants chosen by whatever designers set the pressure, temperature, and inflaton field. Potentially, we could craft the perfect conditions for life. Some theories say our universe might have started the same way. Andre Linde, the Russian-American physicist who helped develop the inflationary universe theory, says, "If I wanted to send a message to the inhabitants of the universe I created, I would write it down in the local laws of physics, and to transmit a long and meaningful message, I would have to make these laws quite complex. For example, it is necessary to take care that the masses of electron, proton, and neutron are in non-trivial relations, the unraveling of which will be a serious task for future physicists. Therefore, it is possible that we, without knowing it, are trying to decipher coded messages from the superintelligent, but certainly not divine, creators of our world." Sabine Hossenfelder interviewed physicist Zia Morali, author of A Big Bang in a Little Room, a book about whether we can ever build our own universe. Morali found that top physicists, much to her surprise, didn't just talk nuts and bolts science. They also freely admit philosophical musings. As Morali puts it, what surprised me was how much they thought about these questions. Scientists said very personal things, expressed confusion, admitted they didn't always know what to think. They're incredibly rigorous about physics, but can still be emotional and openly philosophical. They have the same questions and insecurities as the rest of us, and they're willing to say, "I don't have an answer." I wanted to show that in my book because people often believe science just shuts down these conversations. But here they were, being humble, saying, "I don't know." In London's British Library Plaza, a repository of staggering scientific knowledge, you'll find a massive bronze sculpture named Newton, directly referencing William Blake's work. You'd think, given Blake's hatred for Newtonian science, this would be the worst statue to erect in front of a temple of knowledge. But maybe that's exactly the point. It's there to remind us that while the human mind is a mighty lens on reality, no scientific knowledge will ever be possible if we stay blind to our mind's limits. The deeper symbolism screams that the world is always more than the sum of our theories about it. And hey, maybe we are more than just the sum of our atoms, too. Thanks for watching. Don't forget to like and subscribe to the channel.